In this section, we're going to talk about the first derivative test for extrema, and what that does is it gives us an analytical way of finding maxes and mins and increasing and decreasing intervals of a function without looking at the graph. So it's going to roll back to some previous ideas that we've had, and we will use them in new and exciting ways. So this first idea is increasing and decreasing intervals. And over here in this graph, I have a graph of a function, and the function is the blue one, and the red one is its derivative, just so you can recall the connection between a function and its derivative. One of the things we said previously was when a function is increasing, and this blue one is increasing on this interval and this interval, then we know that our derivative is going to be positive. So just think of derivative as meaning slope, and any time that I do a slope on an increasing portion of a graph, that slope is going to be positive. So that's why you see our derivative graph is graphed above the x-axis on those intervals. And then when a function is decreasing, and my blue function is decreasing all on this portion here, I know that my slope is negative, so I'm looking for my f prime, which is the slope, to be negative. And you see that f prime, this red one, is negative all in here, and it's negative in between this -1 and the 2, because that's where this graph is decreasing. So my f prime is below the x-axis. And previously we also talked about how to find extrema and be able to tell whether they are maximums or minimums. I can see on my graph of f that I have a maximum right here at -1, and on the graph of f prime, it relates to this point right here, and I can see that I'm going from a positive value to a negative value, so I'm going from above to below, and we classified that as a max, and I could see that from the derivative graph. And just going the other way, a minimum point on the graph of f is right here, and the derivative is equal to 0, and I go from a negative value to a positive value at that point. Also, as a reminder, when we were asked to justify, these statements here served as our justifications, so those are going to be important for you to remember. We also said previously that it was very important that you use the name of the function here. So every time you do a justification, you're going to want to reference f prime in every one of your statements. Whereas before we used these from a graph, similar to this example we did here off to the side, today we're going to be doing it analytically, which means our main way of getting this information is using a sign chart. How this is going to work is I'm going to give you an equation, and from that equation you're going to tell me where that function is increasing, where it is decreasing, and where it has max and min points. And you're going to have to do this analytically, which means you don't get a graph, you just have to do it by analyzing the equation. I think we've dabbled with this a little bit in the past, so this might feel a little bit familiar to you. And we've talked about sign charts previously, but they're going to come at us in a big way right now. I've got our steps listed here, these steps 1 through 5 on how to do this process. And our first step is to find these critical numbers, just like we did previously when we did the EVT. That was our first step in those as well. Next, we make a sign chart for f prime, and we start by putting those critical numbers on that sign chart. And those critical numbers are going to divide that number line into different intervals, and we pick a test number from each interval, put it into the factored form of f prime, and determine what the sign is. And we only care about the positive or negative of things because that tells us everything we need to know. If our f prime is positive, then we know that f is increasing. If our f prime is negative, we know that f is decreasing. And by looking at how that sign changes from positive to negative or vice versa, we can determine if we have max or min points as well. Let's go ahead and take a look at an example. In this first example, we're asked to find where this function f of x increases, where it decreases, and just the x value of any max or min points. According to what we set up here, our first step is to find those critical numbers. So I'm going to do f prime and set it equal to 0. And then I'm going to solve this. I'm going to factor out a 6x out of each one of these terms. That leaves me 6x times the quantity x plus 3. And then I set each one of these factors equal to 0, and that gives me 2 critical numbers. There is that second part of finding critical values where you have to consider where f prime does not exist. Since my f prime is a quadratic, it is defined everywhere, so I'm not getting any critical numbers out of this. You don't actually have to write this portion down. I just don't want you to forget that this sometimes will yield a critical number. My next step was to make a sign chart and put these critical numbers on the sign chart. And my sign chart is going to be for f prime because it's f prime's sign, whether it's positive or negative, that's going to answer these questions for me. Make sure when you put these critical numbers on your sign chart, it's a number line, so make sure they go in the right order. So the -3 is going to go first and then the 0. Notice how placing these 2 critical numbers on this number line divides this into 3 distinct intervals. So from -infinity to -3, then from -3 to 0, and then from 0 to infinity. So I have to test each one of these intervals. And I'm going to choose a test number from each interval, and I'm going to substitute it into the factored form of my f prime. It's going to save me a lot of calculations in doing this, and all I care about is, do I get a positive or a negative? So I'm going to pick a number that is less than -3, like -4. And when I put a -4 in for this x times that 6, I'm going to get a negative number. And then when I take a -4 and put it into that other factor and add 3, I also get a negative. And if I multiply 2 negatives together, I get a positive. So I know that f prime is positive on this interval, which in turn tells me that f is increasing. I move on to my next interval between -3 and 0 and just pick a number in there like -1. And when I put a -1 in for my x's, 6 times -1 is going to give me a negative. When I put a -1 in for this x here and add the 3, it's going to be a positive. And if I find the product of a negative and a positive, the result is going to be a negative. So that means f prime is negative on that interval from -3 to 0. And my last interval, I pick a number greater than 0, like 100, and I put it into my factored form of f prime, and it's going to yield positives everywhere. And when I multiply 2 positives, I get a positive. Everything I need to know to answer my questions is sitting here in the sign chart, but I can't use the sign chart as my justification. I have to pull the information out of the sign chart. So first I have to say where f is increasing. I know that f is increasing on this interval from -infinity to -3 and from 0 to infinity because I see my f prime is positive. I know f is decreasing between -3 and 0. And I know that because f prime is negative. And then when I see my f prime go from a positive to a negative, what that indicates is f is going from an increase to a decrease. So f is going from an increase to a decrease. So what's happening right here at the -3 is a maximum on the graph of f. And then here where I see f prime going from a negative value to a positive value, I know at the 0, f is going to have a minimum. Notice that all of my justifications are short, sweet, and to the point, and also that they all mention f prime, in every single one, so just make sure you do that as well. Let's take a look at a few more examples so you can see some variety in these problems. Question number 2, the process is going to be the same, just the function is a little bit different, but I'm going to start by finding g prime, setting it equal to 0. When you do this, don't forget the chain rule that's going on. That's why I have this -1. So bring down the power, derivative of the outside, leave the inside alone, times derivative of the inside. I'm going to clean this up a little bit and then set it equal to 0. Whenever you're trying to get a fraction equal to 0, it's up to that numerator to make that 0 happen. This numerator is locked in at a -2, which means it's never going to happen, so I'm not getting any critical values by that consideration. And then I also have to consider where g prime does not exist, and that's going to happen where that denominator is equal to 0. Just considering where that denominator equals 0 gives me this, and now I just need to solve. Divide by 3 first, and then cube both sides. and I get a critical value of x equals 4. So that's my one and only critical number. And that's the number that I'm going to put on my sign chart. I have two intervals that I need to test. I pick a number less than 4, like 0, and I put it into my g prime right here. That numerator is locked in at a negative, and when I put a 0 down here in the denominator, it's going to be a positive. So I have a negative divided by a positive, which is a negative. I pick a number greater than 4 and do my sign analysis. Again, that numerator is locked into a negative. And when I put a very large number greater than 4 into here, this ends up being a negative value, whose cube root is also negative. Times 3 is going to stay negative, so I'm going to have a negative divided by a negative, which gives me a positive on that interval. And this has all the information I need to answer all of my questions. I just have to summarize it. Here's a summary of what this sign chart is telling me. G decreases from negative infinity to 4 because my g prime is negative. G increases from 4 to infinity because g prime is positive. And because g prime goes from a negative to a positive across this value of 4, I know that g has a minimum at x equals 4. Again, let me call your attention to my justifications and how I mentioned g prime in every single one. We have one more example so you can see how this works with everybody's favorite exponential function. In our last example here, when we go to find f prime, we have to use a product rule. So negative 3x squared is my first, and e to the 4x is my second, and I'm going to product rule this. Here's my first times derivative of the second. Don't forget your chain rule in doing that derivative. Plus the second times derivative of the first, set equal to 0. To solve this, I'm going to clean it up first and then factor. Multiplying and rearranging puts me here, and I look for some common factors. I'm going to factor out a negative 6, an x, and that e to the 4x. Setting each factor equal to 0 is going to give me a 0 for this, so x equals 0 is one number that's going to go on my sign chart. This e to the 4x will never equal 0, so that's not going to give me any critical numbers. Setting this factor equal to 0 gives me x equals negative 1/2. I'm going to ask myself if this f prime is ever undefined or does not exist, and there are no x values that are off limits, so that consideration doesn't yield any critical numbers. So I'm just going to go with the 0 and the negative 1/2 on my sign chart. As I choose numbers on each one of my 3 intervals, I'm going to go back to this version, this factored version, and determine if it's giving me a positive or negative for my selected number. Let's start here with a number less than negative 1/2, like a negative 2. When I put a negative 2 in for this x times that negative 6, it's going to go positive. When I put a negative 2 here, in fact, any number I put for this e to the 4x is going to give me a positive number, no matter what that x is. So when I'm considering this, this is not going to have any effect. It's always going to be positive. When I put that negative 2 here times the 2 plus 1, it gives me a negative. So a negative times the positive that I had from before is going to give me negative value on that interval. There's not really a nice number to pick in between 0 and negative 1/2, but you can do like a negative 1/4. Putting it here for this x, the negative times that negative 6, this is going to go positive. This e to the 4x is always positive. I'm going to put a negative 1/4 here times the 2. It's going to give me a number that's less than 1. So when I add the 1, it's going to go positive. Since all of my factors here ended up being positive, the net result in between negative 1/2 and 0 is a positive. One more interval to go, pick a number greater than 0, like 10. And when I put a 10 in for this x times the negative 6, it's going to go negative. This e will always be a positive. When I put a 10 in here times 2 plus the 1 is going to give a positive. So I have a negative times a positive, which is a negative. The hard part is done. Now all I have to do is summarize what this sign chart is telling me as far as increasing, decreasing, and maxes and mins. Where this f prime has negative values, those are decrease intervals. Just for a little variety, I wrote these as inequalities instead of interval notation, and you could do either one. They're both perfectly acceptable. F is decreasing when x is less than negative 1/2, and also when x is greater than 0 because my f prime has negative value, so f prime is less than 0. F increases on this interval from negative 1/2 to 0 because f prime is positive. F has a min at the negative 1/2 because f prime goes negative to positive. And f has a max at 0 because f prime goes positive to negative. Again, make sure when you do these justifications that you reference that derivative in every single one of these justifications.